Okay, so this video is for the lesson in pre-algebra for Tuesday, the 2nd of March. So I'm finishing up section 4.5, which talks about arithmetic sequences. I'm picking up on page 155. So I'm going to finish 155, 156, and then I'm going to work through some of the homework problems. So we talked in the previous video about the recursive sequences, creating a recursive formula. So in this section, we're talking more about the explicit formula. So to me, the explicit formula is very, very easy, and it eliminates a lot of extra steps that you would have to do if you were only using the recursive formula. So let's see here. If I were to, let's see, go ahead and go to page 155. Let's just look at this. There's a couple of things that might be a good idea to highlight or underline in that paragraph just under skill check 2 on page 155. First is where it defines an explicit formula. So it says the terms of an arithmetic sequence can be described by a formula that uses n to define the position of the term. So remember, when you are looking at a sequence, you are looking at, sorry, that's so crooked, the position of the term in the sequence, and then the term itself, which is the value. So just see here. So position 1, 2, 3, 4, 5 to infinity. And then you have, whatever term. So if we started, say it's 6, and we're increasing it in multiples of 6, and 6, 12, 18, 24, 30, and then to infinity. Well, the position of the term, this is what we call, A, that's A1, that's A2, A3, A4. So we represent the position in terms of A with a subset number. Or if we don't know exactly which position we're calculating, when we write, like in a formula, we write a formula for it and it works for all of them. We just use that position as the letter N. So A N is some unknown position in, and then we need to determine what the value of the term is in that position. So that's where we bring in the explicit formula, which means that AN, so the term at position N, equals the term at position 1 plus N minus 1 times the difference. So remember, D equals the common difference. So you'll notice here that you have an N here and you have an N here. Those are the same value. So whatever position you're trying to find the term for, you're going to take that position, subtract 1. So what you're saying is, whatever position your starting position is, or excuse me, whatever term is in your first position, plus the position number times the difference will give you the term value at position N. I know what I just said sounds like Greek because all of y'all stared at me in class when I explained it this morning. So let me just show you what I'm talking about. Look at the table on page 155. So what they are doing is they have give myself some room here. Table's shaped a little bit different. We have the position of the term, and then we have the term. Not an artist. Okay. I'm not going to go quite as far as they did. 1, 2, 3, 4, 5. Well, 1, 2, 3, 4. Ellipses here to N. Now, the explicit formula, which I gave you before, is AN equals A1 plus N minus 1 times D. So if position 1 has a term value of 3, and you know that D, so I'm going to do A1. Where do I want to put this? I'm going to put it over here. A1 equals 3. D equals 6. So for, is it right? Hold on, I'm just checking myself here. Therefore, a 20. Okay, yes. So if I am looking for position 2, right? Because I'm given position 1, that's A1, and then I'm looking for position 2. Position 2 is represented as A2, right? And then you put in the term for A1, which we see is 3, plus N, which is 2, minus 1 times D, right there on the other side of my table, which is 6. So you see where I got all those numbers? I hope so. If not, just jot a note and I'll go over this when we're face to face again. Okay, so let's simplify. So position 2, we're calculating the term. 2 minus 1 is 1 times 6. So let's continue to simplify. I'm doing this in baby steps here until we get comfortable. 3, again, that's the first number in our sequence. That's A1. 6 times 1 is 6, so that's our difference. So that means that A2 equals 9. So here we have 3 plus 1 times 6 equals 9. And that's what you're looking at when you look. So I've worked through what they show you right there in the middle of page 155. They just went ahead and threw in all the values in here. So I'm going to keep doing that for A3. So, sorry, just so I can keep everything on my screen, I'm going to just erase and repeat, but you go ahead and write it in your notes however you want. So let's do position 2, or excuse me, position 3. So position A3 equals our very first term, which is 3. It's the first one in our sequence, plus N minus 1, that's 3 minus 1, because our N has changed to 3 because we're trying to calculate the term for position 3, times 6. Our difference never changes. So let's simplify here. So A3 equals 3 plus 3 minus 1 is 2, which you'll notice is the number of the preceding position. That's all you're doing is you are that N minus 1 just means the preceding or the previous position number, which if you're calculating 3, the previous one is 2. If you're calculating 4, the previous one is 3, and so on. All right, so that's all we have right there in the parentheses, and that's always going to be the case. So continue to simplify. 2 times 6 is 12. So the value of the term at position 3 or A3 is 15. So I'm just going to write 3, just so it looks just like it does in your book. 3 times 2, or 3 plus 2 times 6 equals 15. Okay. Same thing, position 4. A4 equals 3. That's the term of our first position in the sequence, plus 4 minus 1 times 6. So A4 equals 3 plus 3 times 6. 3 plus 18. So the value of the term at A4 is 21. And so that is 3 plus 3 times 6. I'm going to do the last one, then we're going to, well, there isn't the last one. So that pretty much means that the explicit formula for this, for N, is 3 plus N minus 1 times 6 will calculate you the term for any position in this sequence. even if it goes to infinity. All right. So they have that definition at the bottom. Let's work through example 5 and example 6, and then we'll do skill check 3, and I will work through some of the homework problems. Okay, so example 5 gives us, or this says the explicit formula for the sequence 10, 15, 20, 25, 30, 35 is AN equals 10 plus n minus 1 times 5. It's asking us to find the term at position 60. You can see very quickly why this formula is extremely important, because Lord knows you don't want to have to use that recursive formula 59 times to find the term at position 60. Okay, so let me write all this out. So we have 10, this is our sequence, 15, 20, 25, 30, 35 to infinity. Okay, and then our explicit formula is A, or some position is 10 plus that position number minus 1, or the preceding position number, times 5, which is our difference. And we're being asked to find A60. So if we're being asked to find A60, that replaces our A at position N. We know our position now, 60, equals 10, which is the value of the first term in our sequence, plus 60 minus 1 times 5. So continue, simplify. 60 minus 1 is 59 times 5. 10 plus 59 times 5 is 250 plus 45. So it is, my brain just gave up, 295. There we go. Therefore, the term at position 60 is 305. See, not too hard. It starts to look crazy if you're not used to seeing it with all the ends and the sub numbers, subsets and everything. But once you know what they all stand for, hopefully it's not too terribly confusing. Let's look at example 6 and work through skill check 3. Okay, so for example 6, we have, excuse me, we have the explicit formula, or excuse me, we are asked to write the explicit formula for the sequence -7, -4, -1, 2, 5, and 8. That's our sequence. Then we are asked to find the term at position 72. All right. So what they're doing here is first they want us to create the formula, which we can do, right? We have our A1. So let's go with our base formula. Any position n, the term at position n is equal to the term at position 1 plus the position number minus 1, otherwise known as the previous position number, times the difference. All right, so we know that A1 equals -7. Let's look at the difference. -7 and -4 is a +3. Even though they start negative, they are getting a larger in value, so you know you have a positive difference. So that's a 3. So when we plug that into our base formula, we find that AN equals -7, which is the term at position 1, plus n minus 1 times our difference, which is 3. Now you can simplify this. We want to distribute our difference into the n minus 1, because this way we're creating a simplified formula that we then plug our values into. So when you distribute, you create the formula A at position n equals -7 plus 3n minus 3. So remember, this is 3 times -1 and 3 times a positive n. All right, so then you can combine the -7 and the -3, and you find that A or the term at position n equals -10 plus 3n. And using the commutative property, I would sort of rearrange that so my variable comes first, and I would write it as an equals 3n minus 10. Now, this is our explicit formula for this particular sequence. So now we are being asked to find the term at position 72. So I'm going to take this explicit formula and put it up here and say that A at position 72 equals 3 times n, which is 72, minus 10. Okay, so when you do that, you find that 3 times 72 is 216 minus 10. So the term at position 72 is 206. And so that's what they've done here in example 6. So let's go and work through skill check 3. Go ahead and pause the video and give it a try, and then start the video up to check your answers. So see how you did compared to what I work out here. Okay, skill check 3. All right, so for these 3, they have asked us to find each term using the explicit formula given. Number 1, they want us to find A12 if AN equals 4 plus n minus 1 times 2. So what that's telling us is that our A1 is 4, so that's the beginning of our sequence, and our difference is a positive 2. So we know that because we know that those go into those positions of this formula. So I'm going to do this 2 different ways because when I did it in class, I did it 2 different ways. Let me just clean myself up here, times 2. All right, I'm going to do it just like we did example 6 a minute ago. I'm going to go ahead and simplify my equation, then plug in my position 12 for the value of n. So if I do that, then I end up with an equals 4 plus 2n minus 2. And then we simplify one more time and we find that an equals 2 plus 2n, or 2n plus 2. If you use those mathematical courtesy rules that I explained to you guys, where the variables come first, the constant terms go last. Okay, now we are plugging in what they're asking us to find, A12 for n. So A12 equals 2 plus 2 times 12. So we're plugging in that value for 12 for n. I think I said that funny. Okay. Anyway, so A12 equals 2, and then 2 times 12 is 24. And therefore, the term at position 12 has a value of 26. Okay. Let me do it the other way that I did it in class today with number 2. So number 2, they ask us to find the term at position 51. And they have given us the explicit formula that A in position n equals 4 times n minus 7. Oh, I can't do it with this one. I'll do it with the other one. Never mind. Okay. So in this case, they've already simplified it for us. So we're really just plugging in that 51 for the values of n. So I did that backwards. Position 51 is 4 times 51 minus 7. So we find that, let's see, 4 times 50 is 200, and 4 times 1 is 4, minus 7 means that the term at position 51 is 197. All right, last one here. Okay, so for number 3, they've asked us to find A27 if A1 equals 6 and D equals -3. All right, so in this case, we need to find the formula. Then we need to use the formula to determine the term at position 27. Okay, so this is how I did it when I did it in class. I went ahead and made my formula. So remember, AN equals A1 plus N minus 1 times D. So let's plug that in. I'll do it all at one time. We know that at position 27 is our AN, and that N equals 27. So let's just do it. A27, A at position 27 equals A1, which is 6. Got that up top here. Plus N, which is 27. That's our position number. Minus 1. And then D is -3. So I'm putting it in parentheses too. So I would go ahead and solve inside my parentheses and then multiply them times each other. So 6 plus 27 minus 1, which is 26, times -3. And I find that 6 plus 26, so 3 times 2 is 6. So that's 60 plus 18, so 78, -78. Which makes sense, right? Because our difference between the two is negative, so it's getting smaller. So our number should be pretty small. So the term at position 27 is 6 plus a -78. These are unlike terms, so we find the difference. So 78 minus 6 is 72. And the 78 has the negative. So -72 is our term at position 27. Okay? Okay, I hope that makes sense. So let's see. Let me give you the answers to 1 through 12. So hopefully you can check them. You've already done them and you can check your work and make sure you're right. And then I'm actually gonna let you work through some of the homework problems. And then my video tomorrow will go over all the homework problems. So I'm going to spread this out for you just a little bit. All right, let me give you these answers real quick. So I asked you in the last video to do number 1 through 12 for homework. Number 1 through 4 are fill in the blanks. So number 1 said, if the difference between terms is constant, which means you have a common difference, the sequence is called arithmetic. Or an arithmetic sequence. All right. Number 2 said the difference between succeeding terms is called the common difference. Sorry, I stuttered a little there. Number 3, what kind of formula specifies the step by which each term of the sequence is generated from the preceding step? That's what we call recursive. I know when you try to say that in words, it just all jumbles together in your head for most people. So don't worry if it does. Don't mind the Fortnite goon in the background. Sorry if you can hear that. All right, and then number 4 was an explicit formula allows you to find any term in the sequence without knowing the preceding term. So that's explicit. All right, number 5 through 8, they have given you a sequence and they have asked you to find specific values from that sequence. So number 5 asks you the value of A1. Well, the sequence is 2, 9, 16, 23, 30. So the first term is 2. Number 6 asks you to find D. Well, the difference between all of these, so difference from 2 to 9 is 7. You can double check the other ones, but the difference between 9 and 16 is also 7, 16 and 23 is 7, and so on. And then let's see, number 7 asked you to find the term at position 4. So 1, 2, 3, 4. You should have seen that was 23. They gave that to us. And then they asked us for the term, let's see, position 7. Now, I would go ahead and use your explicit formula for this. So if you want to know what the term is at position 7, it's the term at position 1, which is 2, plus 7 minus 1, which is 6, times the difference, which is 7. I do that right? 7 minus 1 is 6. Difference is, yeah, okay, we're good. So that's 2 plus 6 times 7, which is 42. Therefore, A7 equals 44. Way over there, but that's it. Okay. All right, so let's look at 9 through 12, and then we'll be done for today. So 9 through 12, they have given you A1, they've given you the term at position 1, and they've given you the difference. And they've asked you to find the first 5 terms of the sequence created by those. So for number 9, you should have gotten the answer 6, which they give you. 6 plus 7 is 13. 13 plus 7 is 20. 20 plus 7 is 27. And 27 plus 7 is 34. You really can just do it that way in your head. Enjoy it while it's easy, because it's going to get crazy here soon. All right, number 10, they told us that our term at the first position is -8. Our difference is 3. So A1 is -8. Plus 3 is -5. Plus 3 is -2. Plus 3 is 1. Plus 3 is 4. And that's all she wrote. Number 11, A1 is -10. The difference is 4. So it becomes -10 plus 4 is -6. -6 plus 4 is -2. -2 plus 4 is 2. And 2 plus 4 is 6. All right, last one. Number 12, the term at position 1 is 20. The difference is -8, so we're going down. So A1 is 10. No, not 10, 20. Sorry, 20. 20 minus 8 is 12. 12 minus 8 is 4. 4 minus 8 is -4. -4 minus 8 is -12. And we are done. All right, so homework. Homework is on page 157, which I gave you guys. It's algebra. Number 26 through, I tell them to do through 40. No, number 26 through 36. Right? No, not 26. I'm sorry. 14. 14 through 36. Again, do what you can. Work on it again on Wednesday. I'm going to make one more video tomorrow that goes through all of the homework assignments. And then I'm going to do those word problems, 38 and 40, together with the class. So you can do them with me along in the video as well. All right. Thank you so much. And I will see you later. Bye-bye.